Well, today we're going to talk about inline control structures, which are an extension of regular control structures. So let's get started with that. What we'll be covering today is a very brief, I'm assuming that people here probably have a familiarity with regular control structures, and some of you at least will have inline control structures already, will be familiar with that. But we're going to do a quick, very quick and not in-depth review of regular control structures. And then we'll look at some of the kind of cases that are difficult to code using regular control structures and how inline control structures can make those kinds of cases much easier and straightforward to code. We'll look at the several of well, we look at all of the inline control structure specific keywords, write a couple of utility functions that make it easier to observe the flow of execution through a statement, and then a number of inline control structure examples. So your classic and most very common case, I called it most common, I don't know if it's most common, but it's a very common case of control structures, is the if-else statement, or if and then if-else construct, which you're seeing on the screen here now. And here we just have a condition that is evaluated, and then as a result of that, we either can execute a block of statements that are to be executed when the condition is true, or optionally we can add in an else clause that allows us to have a block of statements that are executed when the condition is false. And so we see the example there with the if function returning then when the condition is true, or returning else when the condition is false. Just a couple of other typical ones that you've seen before, statements like for, while, select, and a few others that exist that are very useful, and they're very efficient. But that's as far as we're going to go with review of control structures, because the primary ones of interest to us here are similar to the if-else statements and the select statement, in some respects similar to the select statement, in that a subset of expressions can be evaluated conditionally. Okay, so key points about regular control structures, just to separate and distinguish them from inline control structures, are that the keywords such as colon if, colon for, colon while all start with a colon, and this keyword is starts as the first non-blank character of a statement. So it can be indented, doesn't have to start at the left margin, but the first character of the expression is a colon, followed by one of the valid keywords like if, for, while, etc. Now let's look at a case that's difficult to code here. So let's say that you have a situation where you want to execute the quote then clause when condition 1 and condition 2 are both true, or when condition 3 and condition 4 are true. You cannot code this directly or easily like I'm showing it below, because the current system doesn't allow mixing of the colon and if and the colon or if conditions together in the same control structure. So if you did code it, as you see at the bottom of the screen, with the if and then the and condition, and then try to mix in an or condition, there are two problems with this. Number one is that we have a rule that you can't mix and or conditions together in the same sequence. But it's also problematic because we don't have a well-defined idea of, if we did allow mixing of and or statement, what the precedence should be relative to one another. That is to say, are we saying that you have to have all of the and conditions to be true first, and then we look at the or that then separates out those. So it gets confusing, and we just don't allow it in regular control structures. So how can you code that? Well, I'm going to show you a complicated and convoluted way of coding it, and then a simple way of coding it, but looking at the disadvantages of using the simple way. So a complicated way to code what I was trying to express in this hard case um, is that let me point out something, is that the conditional evaluation of all of the expressions here, we only can evaluate conditionally as many of the expressions as we need to determine the truth or falseness of the overall expression. So for example, if you had a sequence of and statements, so you had if and then and if this and then and if that, um, as soon as any of the conditions in that and sequence is false, we know that the overall outcome of the evaluation will be false, and we can stop evaluating those conditions and go directly to either the then clause or the or the else clause. If it was a cascade of or conditions, so if we said condition 1 or condition 2 or condition 3 or condition 4, we can stop evaluating those conditions as soon as any one of them is true, because we know the overall outcome of that evaluation will be true. So in the cascade of and conditions, we stop evaluating early, and so if in this particular case, if this was valid, we would um, evaluate condition 1, and if it's false, we don't need to evaluate condition 2, and we would therefore be able to jump directly to statement 5, the then clause, and so forth. So in order to emulate that kind of behavior, the behavior we can't actually express directly in regular APL, I would write a complicated function like this. So this one is simply, I'm using a temporary variable t, I set it to 0, I evaluate condition 1 and condition 2, and if it's true, I set t equal to 1 because condition 1 and 2 are true. Then I'd structure another one. And now this seems silly, I would admit, and you'd be unlikely to code it this way. But if condition 1 wasn't just a variable name, but or it might be a function that had potentially had a high computation cost, or had side effects. So executing it causes something else to happen. Some global state is changed, or something else might happen. And this can be observed. Then it might be important to you that if condition 1 is true, if condition 1 is false, that there's no point in executing condition 2, and we wouldn't execute it. So, and the same with condition 3 and so forth. So to emulate the behavior we were trying to express in this illegal expression, I've coded it here so that if condition 1 and 2 are both true, then we won't bother evaluating condition 3 and 4. But if condition 1 and 2 are not both true, then we would evaluate it. That's why the tilde t here. And then we would evaluate condition 3. And if it was true, we would evaluate condition 4 and then set t to true. And then finally, if t turns out to be true, we will do the then clause and the else clause. So that's the awkward way of doing it. Most of the time, you would probably code it more simply like this, to simply say, if condition 1 and condition 2 are true, or if condition 3 and condition 4 are true, then we'd execute the else clause. But the reason I showed this more complicated scheme here is because I'm trying to emulate the really nice behavior of control structures, in that they do partial evaluations when possible, so that the expressions themselves are only evaluated. We only have the overhead of evaluating expressions if they need be evaluated. And so, as I said, that both if the computation of the quantity is expensive, has a high overhead, or has a side effect that you don't want to execute unless you have to, or unless the condition preceding it is true, then this form of condition, assuming if condition 1, 2, 3, and 4 are all functions, could conceivably be not really what you wanted to execute. So that takes away one of the things that's a big advantage is avoiding execution of conditional expression computation when you don't need to, or when you don't want those effects. So inline control structures were actually the beginning of when I first implemented these. The reason it was precisely to solve this particular problem, where you have a hierarchy of conditions that you want to be able to evaluate. And so with inline control structures, this is a subtle change. But what you're seeing here is, in this easy case, we're coding on line 2 an if statement, but it has a more complicated structure of there, which uses an inline and keyword, and. And what this is saying on statement 2 is that I want to evaluate the condition 1 expression. In this case, it looks like just a variable name, but it might be a function. And we want to evaluate just condition 1. And if it is true, we will go on and evaluate condition 2. So if those are both true, then we don't have to go any farther, because statement 3 is an or condition. So if the first overall expression is true, we can jump to statement 4 and evaluate the then condition. But if condition 1 and condition true, either of those are false, then we have to evaluate the or case, the statement number 3. And again, we're going to evaluate condition 3. And if it is true, we will go on and evaluate condition 4. But if condition 3 is false, we don't need to evaluate, and we will not evaluate condition 4. And we will be able to jump directly to statement 6, because we know that as soon as condition 3 is false, we determine it. We don't need to evaluate condition 4, because there's no value of condition 4 that could cause the and combination of condition 3 and 4 to yield a truth, and therefore we will be able to skip that evaluation. And this is really the important part of a very important aspect of control structures, and in particular of inline control structures, is the ability to only to selectively execute expressions, and only execute those parts of the expression that are necessary to do that. So we can see how we can structure using the inline control the and keyword here, that we can break this down into the and or, but we can also use parentheses to group these together, as you see in the easy2 case in the function that's at the bottom of the screen. So in that case, we're doing condition 1 and 2 all in parens, or the stuff that's condition 3 and 4. And so it's very similar to the case above, but it's all expressed in statement 2 instead of in statement 2 and 3. And for complicated expressions, then this is a great way of expressing that. And okay, so let me move on here. So here's the list of all of the inline control structure keywords. First of all, they all start like with regular keywords. They start with a colon, but they don't start at the beginning of a statement. So a distinguishing feature of an inline control structure keyword is that it looks like a regular keyword, but it is never the first control structure keyword on a statement. So it will be somewhere else embedded in the statement. And the keywords that are available, there's one that's not shown here, and that is the in keyword that's part of the for statement. But that one's kind of funny, and we're not going to worry about it. We're not going to really think of it as an inline control structure keyword, even though it kind of is. It follows the rules here, but it simply is really used as a syntactic separator between the target variable. In a for statement, it's used as a separator between the target variable and the iteration array values. but so I didn't list it here because it sort of pre-existed before inline control structures were invented. It was invented as part of the :4 and for each statements. So I'll set that aside. But the keywords that we have for inline control structures are and, or, then, else, choose, and res. So we'll make examples for each of those. We've kind of looked at the and or already. They are sequentially evaluated for truth, and we can stop evaluating the continuing expressions as soon as we know, based on what we evaluated so far, the overall, what we can surmise what the overall truth or falseness of the expression will be. And as soon as we've determined that, we can stop the sequence. So a sequence of and um, uh, conjunctions can stop as soon as any of the parts of it are determined to be false. We know the overall outcome will be false. And a series of or constructs, as soon as any one of the sub-expressions are true, we can stop evaluating the rest of them because we know the overall outcome will be true. So that's your and or expression. Then and else. We've seen an else keyword in regular control structures, but it can also be embedded within a line, and we'll look at that in just a moment here. The then keyword is a new one that was added as part of inline control structures, because normally in a normal if else type of a statement, the then clause, the conditional true execution clause, is simply on the next line or next statement. So if you have an if statement with a condition on it, then the next statement that follows that will give you the will be the target of execution if the condition is true. In an inline statement, which we'll see just in a moment, the then clause is said, what do we do if the conditions to the left of it are true? Then we will execute the expression to its immediate right of the then clause. And the else will be executed if we didn't execute the then clause. So if we have an expression that's true there. And then the choose clause is used to select via an index. So, you know, 1 through n, any number of a collection of sub-expressions, target expressions, but we only want to evaluate one of them. So we don't have to pre-compute all of them as you would in a normal APL expression. Or we don't have to structure a multi-line select statement to select the particular case and so forth. And finally, the res statement is used in conjunction with the return if. So we'll come and I won't say much more about it right now, but we'll move on to these. So let's take a look. Before we actually look at the cascade of these, in order to kind of make it more clear, the way the partial execution of expressions is done, I've written two functions that I'll use in the demo here. A function called true, that's a monadic function that takes an argument that gets formatted and displayed, so that execution of true, whatever the argument is, will end up, as you see near the bottom of the screen. If I say true 1, it displays true : 1 in the session log, and then it returns the value 1, which represents true. The false function, similarly, it displays a message also. It takes its argument, formats it, and concatenates it to the false colon. So executing false 2 produces an output of false : 2, but then it returns a 0. So we're going to use this true with its argument and false with its argument as part of control structure expressions, so that you can see the sequence of execution that occurs as a function of different argument values. So let's take a look at this. So here's a case that's using the and construct along with the then and else keywords. So the first expression, we evaluate the statement to the left of the and, which is true 1. And we know that we've executed that because of the first output that we see, which is true : 1. The argument to the true function gets displayed following the colon. And then because it was true, we have to also evaluate the second expression, true 2, to find out if it's true or false. And in order to determine whether we want to execute the then clause or the else clause. And so it is also, since we're calling the true function, it's going to return a 1. So this expression and true 1 and true 2 will have an overall truth value, which means we're going to select the then clause to execute. So we do that, and that's what we see in the output. So we can see that the case of true 1 and true 2 yields a overall truth value, which selects the then clause for execution, and we don't execute the else clause. In the next expression, the first expression is false 1, and that returns a 0, representing falsity. And in a sequence of and statements, we're done with the evaluation. As soon as in a sequence of and conjunctions we find any of the partial results to return false, we know that the overall expression has to be false, because the and of it with something else will not yield. No matter what the other expressions evaluate to, it will never yield a truth expression. So we don't bother, and you can see that we don't execute the true 2 expression. We don't see any output from it. So we skip that and we go directly to the else clause and execute it. So in the first case above, well, I basically have explained, I guess, what my notes say here. Okay, so and when we get to questions, if anybody has any questions here, we'll roll back to the appropriate slide and address those. Okay, so here's a bit of a trickier case. Let's say that you don't just want to execute the clause, but you want to assign it to your result variable. You would be tempted, and you will probably make this mistake at least a few times, to code it like that first line. Res is assigned and then everything to the right of it. But the problem is it executes properly in that it does execute and return it does evaluate the then clause, but it does not assign that to res. What gets assigned to res, what we can see in that first expression, is the value 1. And the reason is that the way the control structures are executed, the entire expression res is assigned true 1 is the expression to the left of the and statement that gets evaluated. So we're assigning res to the value of the left argument to the and keyword. That's why res is being assigned 1. And that's not what you want to do. But you can make this produce the result you want using parens. So you'll notice in the second expression, we're assigning res is assigned, and then the entire expression to the right is enclosed in parens, and we are going to evaluate true 1 and true 2, and if those are both true, which they are, we'll evaluate the then clause, and that will cause the value of the then, whatever the value of this expression, in this case then, will be assigned to res, and that's what we see happening when we execute it. We see that the result of the value then, it has been assigned to res, which was probably what was intended when a person would code the first expression, thinking that the res would be the overall result. And then the third expression simply uses to the left of the and is a false value, which causes the else clause to be executed, and its expression is evaluated there. So we accomplish our goal in the second and third clause by using the parens around the expression. Now you might also be tempted to use it this way. And you can code it this way, but unfortunately there's a bug here. And this is a bug that exists in APL plus Win and APL 64. And I just discovered it when I was writing up this presentation, in fact, and didn't realize that it was actually present as a bug in the system. So I've written this up as a bug report and we'll address it, or we'll decide how to deal with this. But here's in a normal case of an assignment statement that appears on an APL statement, if you do an assignment as the last operation, the leftmost operation on a statement, that causes the result value to not be displayed by default. You don't get default output. But what's happening in this case is we are successfully assigning the the value of the then clause. But what you'll notice is that the then is still being displayed in the third line of output here. So the normal suppression of display of output that occurs when you do an assignment as the last operation on a statement isn't working when it's embedded inside of a sequence like this then clause. And I believe that that's incorrect. You also cannot suppress it using a monadic assignment arrow. So normally you can sync output or suppress output. So if I coded this without using the res variable name, it would give you a syntax error if I coded it as colon then and then left arrow then was in quotes. That would actually give me a syntax error in the expression. So there's a bug there, but you can do this, but the problem is you really probably don't want that to be displayed as output. You don't want the then or the else to be displayed as output. So you really want to code it more like this if you're trying to assign it, rather than embedding the assignments inside like that. Okay. So with inline control structures, just like with regular control structures, you cannot mix a sequence of and or statements in the same expression. But unlike regular control structures, you can use parens inside of those expressions to control the order of execution and achieve what you're after. So in this first expression, I can't say a true condition 1 and condition 2 or condition 3 or and condition 4. That mixing of the sequence of and ors together in the same expression isn't allowed. But I can use parens to group it, so I can say condition 1 and condition 2 all in parens, or condition 3 and condition 4 all in parens, and that's perfectly valid. And if those both evaluate, if either to the left side of the or the right side of the or evaluates to true, we will select the then clause. Otherwise, we'll select the else clause. And I didn't give an example of an else clause evaluating, but what you do see different is you can see that we had to evaluate the first expression, true 1 and then true 2, because to find that they're both true, and then we can skip the true 3 and true 4 evaluation and skip to the then case to get that executed. And then but similarly in the last line, we evaluate true 1, and that's true. So then we go on and evaluate the next expression, which is false 2, which returns false, and that makes the overall expression true 1 and false 2 false. So therefore, we have to evaluate the or condition. So we go on then and evaluate true 3, that's true, and then we evaluate true 4, and that's true. So the right-hand side of the or becomes overall true, and we execute the then expression here. If we had put a false 3 or a false 4 into this expression, then we would have selected the else statement instead. So, okay. The other thing too is to note that inside of the original regular control structures had to be coded like you see on the top left, where if you had a condition, you'd have if some condition, and then you could say and if another condition. So you can, but you can abbreviate the and if keyword to simply be colon and. You don't have to say and if as an extension of this in regular control structure expressions. But the reverse is not true. So in an inline control structure, the keyword colon and colon or are defined as being inline keywords that are valid. But you can't, so the bottom left expression of 1 colon and 1 colon then is valid and evaluates correctly. But if I tried to code this using and if instead of colon and, I get a syntax error. So they're one-way interchangeable. I can use the abbreviation colon and colon or in place of colon and if and colon or if. And that just makes it a little easier to type your control structure keywords in regular control structures. But the and if and or if are not a valid part of inline control structure expressions. All right. Another gotcha here is that and this is really done for historical syntax analysis reasons, but if you code an inline control structure like you see near the top of the screen, you'll get that name, if it's a simple variable name to the left of the colon at the beginning of a line, gets interpreted as a statement label. So condition space colon and does not get seen by the syntax analyzer as a colon and keyword. Instead, it gets seen as the name condition, C-O-N-D, being a name of a label and it's followed by a colon. The syntax rules, the historical syntax rules for APL Plus have been a name followed by a colon, whether it's adjacent, the colon is adjacent to the name or separated by spaces, is interpreted as a label. And we didn't break that rule. So that's how it's evaluated. And therefore, if I tried to evaluate this expression, I get an outer syntax error in this case, because in this case, this was done in immediate execution, and a label is not allowed inside of a expression. You can't define a label inside of immediate execution expression. It's not valid there. If we phrase this inside of a function, we get a little different behavior, because in that case, the label is on line 2, COND space colon is seen as being a label designation. And then on line 1, because it's defined, when we define the function, that means COND is considered to be a statement label. And it's constant, you can't assign to it. So when we try to execute the function, we get a constant error. Label cannot be modified on statement 1, because we're trying to assign to COND, which we intended to use as the left argument of the then keyword, but that's not how it got interpreted syntactically. So that is a little bit of an issue that you might run up against with these, but you can work around this easily using either parentheses, or if the expression is more than just a simple name. So in this first example, I've assigned a variable COND equal to 1, and then I can put parens around COND, and that will be sufficient to differentiate it so it's syntactically unambiguous that this is not intended to be a statement label. Or I could put parens around the entire expression, as you see in the second expression. Or I could have a more complicated expression than a simple referencing a variable. So in the third case, I'm testing is COND equal to 0, and that doesn't get interpreted as a statement label to the left of the then, to the colon of the then statement. And finally, I could also, and not necessarily recommending this as the best construct, but it's sufficient. I'm raveling the COND value here, which differentiates it from being a variable. But the point of it is I can use an expression. And I also want to emphasize the fact that oftentimes, if you've evaluated down to a single expression stored in a variable, that might be perfectly appropriate to use as an argument as part of a conditional expression being evaluated using inline control structures. But one of the nice advantages of inline control structures, especially for secondary and tertiary pieces of, say, a sequence of AND keywords that are joining together several things, is that the sub-expression, which could potentially be expensive to compute if you're calling a function that does a lot of work, it doesn't have to be evaluated if the condition, the overall condition, can be predetermined to be true. So a advantage of using nothing wrong with using just a variable. You just have to be careful of this particular case. But you can code complicated expressions in these clauses, especially when you don't want to incur the overhead of those expressions if we can evaluate the truthness or the falseness of an expression sequence based on the previously evaluated things. We don't have to continue the evaluation. So, but most often I will say you'll find that these inline control structures are very often end up getting used in conjunction with regular control statements. So similar to what you see here on the screen, where I have an if statement that has multiple conjunctions following it. So it's going to evaluate through those, and it simply is, you in this particular case, you could have just expressed it using regular control structures as if condition on line 1, and then a new and colon and on the second statement, and then another and statement keyword on the third statement, and those would have been perfectly equivalent. But of course, if you're mixing in ands and ors together, as we've illustrated already, you would end up using some parens and things around them to group them. So but oftentimes you don't need to worry about this thing of the label interpretation, because you'll often be something else on the statement before you get to that. But just be aware of that. Okay, we're going to move to the choose expression next. And the choose expression is the left argument to the choose keyword is an index that determines which of the sub expressions will be evaluated, and only that sub expression is evaluated. So this is very distinct from the example at the bottom of the screen. So in the first case, 1 colon choose means we're going to evaluate the first of those expressions. Notice all the sub expressions are just separated by colons from one another. So we're going to evaluate the expression of A catenate 1 is the expression, and that's the only one that we evaluate there. The B catenate 2 and the C catenate 3 didn't get evaluated at all as part of this execution. We only evaluate the piece that we need here. And so the 2 choose evaluates the second expression. A 3 choose would evaluate the third expression only. Any other index value, like a 0 or a 4, will execute the else clause if there is an else clause. And you could put all of this whole thing inside of parentheses and assign the result to a variable, or if you want to pass it as an argument to a function, you could put the whole thing in parens and evaluate it that way. But important point to note is that of the sub expressions, the chosen expression, only the selected expression is executed. So there's no overhead of it like you would here. So if you look at this bottom expression, which is similar to the first 2 cases, where you're using an index to pick from a list of items, the difference here is that in the case at the bottom of the screen, where we're forming a nested array that contains these expressions, all of this evaluation has to be done before we do the pick to select which of those expressions. So we've evaluated A catenate 1 and B catenate 2 and C catenate 3, and we've joined them all together into a nested array. We have all of that overhead, and then we pick an item. And using the choose expression, your index selects only the expression that you're interested in for evaluation. So if you were making, these are relatively simple expressions, but if you had more complicated computations, the choose is a far better way to select one and only execute the piece of code that you're interested in. Now, you could easily do something similar to this using the select statement, the regular control structure statement, the select statement with a case 1, case 2, case 3, and so forth, and do that assignment. But it's a little more cumbersome if you wanted to assign the whole thing to a result value. Then the select statement, you'd have to do the assignment on each of the cases inside your select statement, whereas you could just throw parens around this whole expression and assign it to a variable or pass it as an argument to a function if you used the choose expression. And finally, we're going to get to the last of the inline control structure keywords, which is the :res expression. And this is only valid to use in combination with the return if statement. The return if statement is a classic control structure expression that evaluates an expression and returns from the calling function if the expression is true. And so and then the result value, however, would already have had to be pre-assigned, pre-computed and pre-assigned. The res statement allows you to defer the computation and assignment of the result variable as a conditional secondary part. So I could code return if condition, and on the way to doing the return, the :res keyword says, to the right of that is the actual value I want to return, which could be a complicated expression, not just quote true as in this case. So if the condition is true, we want it to return the value true. Otherwise, in this case, we're going to fall down to line 2 if it's not true, and we will return the value false. So as you can see on the left-hand side, the execution of res 1 will return true, and the execution of res 0 will return false. Over on the right-hand side of the screen, you can see how we could code this using regular if-else logic and just return a 1 or a 2. That's functionally equivalent to it. And in this particular case, it is equally efficient to it. But there are cases where return if is very handy to use because you've got a series of conditions you might be returning and you return it. But without the :res keyword, you would have had to pre-assign the result variable, z in this case, with a value that you want to return before you get to the return if. But if you want to use the return if rather than the if-else type structure to do this, you can do so and use the res keyword. So that's really the last of those, and so the remaining time we will just use for questions. And I spoke a little longer than I intended to, but there you have it. Okay,